tunneling, which allows particles to cross classically impenetrable barriers. Even the notion of entanglement, famously described by Einstein as spooky action at a distance.
People, when your sophomoric view of the world, Isaac Newton was wrong. Isaac Newton was pretty flippin' right.
Defied common sense by linking particles across vast distances. Yet despite these remarkable behaviors, the idea that our universe could intermittently interact with an adjacent reality was once thought to be purely speculative. The new findings are now beginning to bridge that gap between theory and observation. Researchers speculate that what they observed might be a delicate interference pattern, evidence of information seeping in from a hidden dimension. If subsequent experiments confirm that these fluctuations are not mere artifacts of the quantum system, it would imply that our reality is more porous than we have imagined. A tiny window may have opened through which information from a parallel universe is influencing our own. Breaking this theoretical barrier is revolutionary. Not only does it challenge the very definition of solidity in our physical existence, but it also suggests that the many worlds interpretation, where every quantum event branches into multiple realities, might hold more than just mathematical interest. It encourages the scientific community to re-examine the nature of time, space, and the limits of what we can detect and control. As experiments continue and data accumulates, the possibility of directly mapping or even manipulating these parallel realms could transform our approach to physics and technology, forever altering our understanding of the cosmos. Quantum computing as the key to unlocking hidden dimensions. Recent advances in quantum computing are rapidly changing the way we view our universe, suggesting that our three-dimensional reality may be just one layer of a far more complex, multi-dimensional cosmos. Quantum computers use qubits that exist in multiple states at once, thanks to the property of superposition. This ability makes them not only powerful computational devices, but also uniquely suited to detect and analyze subtle phenomena that could hint at hidden dimensions. In a typical experiment, scientists program quantum gates to manipulate qubits in well-controlled settings. When these qubits interact, phenomena like quantum entanglement occur, where changes in one particle instantly affect another, regardless of distance. Researchers believe that entanglement, along with quantum tunneling, where particles pass through barriers in seemingly impossible ways, may be the key to noticing how different layers of reality interact. These same principles are what experts suspect might reveal the presence of hidden dimension. The idea is that our universe might be interwoven with alternate realities, each acting like an overlapping layer of existence. As quantum computers process a vast number of quantum interactions at speeds no traditional computer can match, they become exceptional tools for detecting minute fluctuations. Such disturbances, if measured accurately, might be signals from another realm, a hidden dimension influencing our measurements. In experiments conducted in various labs, including those at high-profile centers like CERN and tech innovators such as Google's Quantum AI Lab, researchers have noticed anomalies that defy the expectations of classical physics. These anomalies are seen as potential footprints of interactions between our known reality and an unseen one. Scientists are now designing protocols to isolate and study these unusual signatures. The hope is that by refining their techniques, quantum computers can help map out these hidden layers with unprecedented precision. If successful, this line of inquiry would not only confirm the existence of parallel dimensions, but also teach us how information, energy, or even matter might transit between them. The implications extend from a deeper understanding of the universe itself to practical applications, such as revolutionary data processing or novel forms of communication that leverage interdimensional channel. Quantum computers are emerging as indispensable instruments in the quest to unlock the universe's hidden dimensions. Their ability to harness the peculiar behaviors of quantum mechanics opens a pathway for us to peer into and possibly interact with realms that were once considered the exclusive domain of theoretical speculation and science fiction. As research advances, the dream of mapping and even tapping into these alternate layers of reality grows closer to becoming a scientific breakthrough that could redefine our understanding of existence. The many worlds interpretation. One of the most captivating ideas emerging from quantum mechanics is the many worlds interpretation, the theory that every quantum event gives rise to multiple coexisting realities. Recent experiments using quantum computers are now providing intriguing hints that support this mind-bending concept. When a quantum event occurs, as in the state change detected in a controlled laboratory setup, the universe appears to split into several parallel tracks. Each possible outcome spawns its own timeline, where everything that could possibly happen does occur in some version of reality. This experiment, which recorded simultaneous molecule measurements from distant locations,